lecture sections because there are another two groups to take this AI course, so they have a different timetable also. So total I think will be around 200 students to take this midterm test lah, as well as the final. So probably I will set 6:30 to 8. But on which day I need Saturday. Saturday. No Saturday. Replacement. Don't want to have replacement. For the next week, next Friday, yes. For the what so called the election. Next Friday, no class, right? You got a message, right? The memo. So we can replace the class online for Friday. But for the public holiday, for the others public holidays, no. Who is the course rep for course?
Brendan.
Good. Brendan.
Brendan.
So I need your help to in the week 9 or week 10 you try me to find out any 90 minutes 1 hour and 30 minutes any slot. Probably after 6 months because it's very hard to match the time. So either is maybe Thursday.
I only know my course only one.
Your course. I want your course.
Only one.
Not one class, for whole course.
Oh yeah.
GG.
Yeah, I need to coordinate you coordinate with the other cross reps, right? To find which day, is free after 6:30 to 8. So only 2 questions, probably only 2 questions.
How to question?
Yeah.
Each question 25 marks. Each question.
Yeah. Very clever. Objective. No.
ABC
Subjective.
MCQ
Subjective.
Need to draw diagram.
Need to draw diagram. Yeah, probably you need to draw for chapter 2, right? 3.
So week 几 conduct a week.
Either week 9 or week 10 lah. So at least you got the time to study lah. Week 9 or week 10. So can Brenda? You let me know which day.
Can I use the Google Classroom to ask everyone to put a picture of their timetable and I just
Can also.
can I just do that?
Okay. Afternoon So next Saturday we have a election, right? State election. So make sure that you never involve, go back and vote for your party. It's going to decide which party to govern your state for the next 5 years. Anyone from Selangor, Kedah, Kelantan? Remember, your vote is very important. Your vote is very important. Don't think that only one vote never mind. If everyone think like you, then you are the future. So you have the responsibility to vote for your state. So I no need to go back because I'm from Perak. So Perak we already vote for during the general election. So I'm not going to vote for this time. For those who involve remembers, you have to go back. Okay. So it's 12:15 I think it's not yet. It's not. Let me count. 1, 2, 3. About 70-80%. So it's okay. So I think we should start our class. As usual. So a summary for the past few weeks, right? For the past few weeks. So this is a new topic. It's not relevant at all to the paths and algorithms. No. It's a new topic. So before we start the new topic, let's summarize first. That's what we have learned actually during chapter 2, 3, and 4. So chapter 2, chapter 3, and chapter 4. So these 2, 3, and 4 are basically for path search applications. So for example, Google Map, Waze. Okay, Google Map, Waze, Puzzle, the Cannibal Missionaries. And then in the chapter 2, we learn about the planning. Okay, so before we start the algorithms, so you probably have to formulate a problem. Okay, and also to formulate the goal. Okay, so you have 7 elements under the problem lah. So this one I'm not going to list out everything here. For example, successor functions, the state space, the stack cost, the path cost, right? So I think during the tutorial I already explained. Maybe not all of the group, some of the group already go through the tutorial questions. So I already explained to you how to define the problems and also as well as the goal lah. So you have a goal, optimal solutions, and also the abstractions. So this one you have 7 elements here. Okay, so once we have done the planning, then we move on to the algorithm. Okay, so we move on to the algorithm. So there are 2 types of algorithms here. So one is the blind search, or we call it as a uninformed search. So and then another one would be a heuristic search, or we call it as a informed search.
Heuristic.
Okay, so blind search is solely depends on the patterns. Okay, meanwhile the heuristic search, it depends on the informations given. Okay, for example, the time, the distance. So we are going to use this information to explore the path. Blind search here we have several quite famous algorithm. For example, depth first search, breadth first search. We have others more interactive deepening depth first search, so-called depth limit search, bidirectional search. But these 2 are the famous one. So depth first search is you go deeper and deeper vertically. Okay, vertically. Breadth first search, go horizontally. Okay, so depends on the patterns. So what is the limitation for blind search? You're going to waste a lot of time. Waste time and the memory, because even though you know that the solution is somewhere around here, you have to explore also, because it depends on the patterns. Okay, what is a heuristic search? Informed search, it depends on the time. So we have learned about the hill climb. The hill climb here is divided into 2 types of algorithms. A simple hill climb. So many discussion here. Okay, yeah? So we have a simple hill climb and steepest ascent hill climb. Like a superpower, you look back, then no sound. I can turn back, then yes.
You want the top? She wants the top.
Okay, simple hill climb is like a depth first search, right? So it explore. As long as the child node is better than the parent's node, then we explore. We explore. So if the child node is worse than the parent's node, then we stop it here. Steepest ascent is we explore all. We choose which one is the best. Okay, then we explore. Let's say this is the best, we explore. Okay, so this is the best, we explore. Okay, if the child's node is worse than the parent's one, we stop here. So the problem of the hill climb here is local maxima. So this one you have seen. We have a foothill. What else? Plateau, yeah, very good. And bridge, right? And then we improve these hill climbs using best first search. Right, best first is a combination of a breadth first search and also depth first search. And then after that we have a A-star. Right, very good. So best first we use a heuristic cost. A-star we use function cost, which is the path cost plus the heuristic cost. So the way they expand are the same. So last week I already showed you the path, right? How to use the open and close to expand the path. So this is a summary of the chapter 2, 3, and 4. It's about the path search. So now you learn about the path search, you can actually build your own applications. let's say the egg tile puzzle, you can play with your sibling. Okay, see who win the games, right? You know already which part is actually lead you to the least number of station or least number of steps towards the goal. Okay, morning, afternoon. Okay, so yeah. So let's move on to the new topic called knowledge representation. It's one of the very simple topic I would say is overall in the 13th chapter is considered a simple one. So forget about this. You can throw this chapter 2, 3 and 4 into dustbin. Before the midterm test, you have to revise. Now you can keep away. So we are going to move on to the new topic called knowledge representations. So in the upcoming chapter 5 and 6 here, okay, chapter 5 and 6 is about NLP. Okay, natural language processing. So I believe you have gone through the practical for NLP. So you know what is NLP, right? Natural language processing. Before we build any NLP, natural language processing, the first step we have to do is to represent the knowledge first. So what is knowledge representation? Is a very important process to organize, structure, and also store the information so that the machine and the human can understand easily. Okay, so what is the knowledge representation? It's a process that used to organize, structure, store the information so that it can be easily understood by human and also the machine. Okay, so why we need to structure the information or this? Because in our real life there are too many words. There are too many words. For example, happy. Okay, for example, happy, we have excited, we have a sad, we have so many words in the life. So what is the relationship between this and this? So we have to declare first. We have to represent what is the relationship between happy and excited, what is the relationship between happy and sad. So we have to declare first. So why we need to declare? Because it is easy for the machine to understand. Machines doesn't understand the meaning, the actual meaning of what is happy, but they understand through what? Through the comparison. Okay, I repeat again. Machine doesn't understand the actual meaning, just like human. We look at the dictionary, we look at the meanings, then we understand. But the machine no. Machine cannot understand the actual meaning, but they understand through what? Through this kind of mind map, a comparison between this and this. Then they can understand. Okay, so look at this example here. Okay, so let's say now you go to the Google search. It's one of the NLP applications. You ask what is book. So you look at the result here. So you written your book proposal. What is ebook? Then somehow you will see that why it show what is a novel. How come the machine knows that book has some relationship to novel? How this works? Okay, and also if you type half an hour, it will return you is half an hour 30 minutes. How does half an hour 30 minutes right equal to 30?
Who the hell asked this question? People also ask what people brain dead is it?
Mean for example so how does the machine knows that half an hour is equal to 30 minutes? What is the relationship between 30 minutes and half an hour? So it's actually done using techniques called WordNet. Okay, so what is WordNet here? It's actually a lexical database. Okay, that to store all the lexical means the meanings, the words the words. Store all the lexicals in using so-called synonyms, antonyms, hypernyms. You do know what is synonyms? Synonym is like the words that having similar meanings. Okay, for example, happy, excited. So this is the synonyms. Happy and sad is the antonyms. Okay, so this is the synonyms. Okay, we have a hypernyms. Okay, we have a hyponyms. So what is hyponym? What is hypernym? Hyper is a kind of a concept. For example, flower. Okay. Hypo is a subclass to the flower. For example, rose. A rose is a hypernym to the flower. Flower is a hypernym to the rose. So the WordNet is built through this kind of concept, through the hyponyms, antonyms, this and so on and so forth. So look like this. this word net. It's a net that consists of all the lexicals or the word nets. For example, if you search for the book, it will relate you to the novel. Why? Because in the word net here, there is some relationship between the book and the novel. Same goes to the half an hour. Okay, so there is a relationship between half an hour and 30 minutes. So that's why in the Google, if you type half an hour, it will return you some response related to 30 minutes. Okay, because there is some relationship. So who built this word net? It's actually built by one of the university called Princeton University. Some researchers, they find all the words, they understand the meaning, and then they build the word nets and then they put it inside the Python library and LTK, then you can use it. For example, I'm going to show you one here. Okay, let's say word net is also one of the very powerful so-called lexical database in NLTK. So let's say now I'm trying to ask half an hour. Okay, so what is the synonyms of a half an hour? If I run this code, so it will return me 30 minutes. So there is a relationship between half an hour and 30 minutes. So no matter you ask 30 minutes, the machine will know that, oh, this is actually half an hour. Okay, there is some relationship between these two terms. Okay, so there's no antonyms for the half an hour. The synonyms in the word net is called syntax the syntax. It's just terms. Okay, so that's why knowledge representation is very important. It's very important that how do we actually represent the knowledge from the unstructured data to the structured data, so that the machine can understand the so-called meanings, but not through the actual meaning, but through maybe the relationship, through the comparison, through how you represent the knowledge. Okay, you will represent in the wrong way, then the machine will interpret wrongly. So one of the reasons why you need this one is for the machine to interpret, to analyze, and come up with the conclusions. Okay. All right. So there are several techniques to represent the knowledge. Okay. One of the famous one is called semantic networks. Okay. Semantic network is a network to show all the semantic. What is semantic? Semantic means a kind of words or the meanings. So you have a network to represent all the semantic, all the relationship. What is conceptual graph? So we have a semantic network, a conceptual graph. We have an OR graph. Okay, and the last one is the frames. So each technique here has its own purpose So normally we use a semantic network and conceptual graph to show the relationship between the concept. For example, what is the relationship between happy and sad? What is the relationship between excited and happy? Besides, we also use the semantic network or the conceptual graph to show the sequence of events. Okay, for example, today you play games, so inside the game you fight with the boss. Okay, after the boss you win the reward. So it shows the sequence of events. Okay, so we use an AND OR graph to represent the rule base. Okay, we have an example later. And last one, we have a frame. Normally we use a frame to represent the properties of one object. Okay. So frame is not suitable to represent relationship or sequence of events, but it's more suitable to represent properties. Semantic net and conceptual graph is not suitable to represent properties because you're going to have a lot of branches here. So let's see the example of semantic networks. So this one is not important here. So what is semantic networks? Is to show the relationship to other concepts. So under the concept semantic networks, there are several terms that you have to take note. The first one is called node. I think it's shown here. Yeah. The first one, node. Node here is to show the concept. Okay, so this is the node to show the concept. This is a concept. This is a concept. And then the second one, we have this so-called edges or the label arch here. Okay, so we have a label arch here. Okay, normally it's a binary relationship. It's a binary relationship. So this arch here to join the concept to show what is the relationship between the concept A and the concept B. Okay, and lastly, you need to provide the label for this label art. What is the relationship between A and B? Maybe A is a subclass to B. Then it shows the relationship between the concepts. Okay, so look at these examples. We have a human, right? Human is a mammal, right? What is mammal? What is mammal? You know Chinese, right? What is mammal? What is the properties of mammal? Vertebrate. Yeah, you have a backbone. What else? Don't know. Forgot already. Yeah, science. So human is a mammals. Other type of mammals like monkey, alligators. So human is a subclass. It's not an example, but it's a subclass to the mammal. Okay, mammal is maybe a superclass. Okay, then we show the relationship between human and the nose, right? Human, all the human we know that has a nose. Then we have a concept here, so by note. Then we have a so-called the edge here to show the relationship. Human has a nose. Then we have another so-called example or the instant. Okay, Simon is the instant to the human. So Simon tutorial group maybe in L1, and the Simon the favorite number is 8. Okay, so there's no such standard syntax for semantic networks. As long as the relationship here is logic, then it's considered correct. You can use your own so-called the terms here, right? Maybe Simon, a tutorial group, okay, can also. Simon, lucky number, can be, okay. So it's up to the user how to define the terms, the relationship. But somehow, but for the is and instant, you have to take note lah. So it's quite different between is and a instant here. Is so a subclass. Human is a subclass to the mammal. Maybe you have a monkey is a subclass to the mammals. But Simon is just one of the examples. For example, you have Jason is instant to the humans. Me is instant to the humans. You have a vehicle. Vehicle is a class. Then maybe MPV car is a subclass. It's a subclass to the vehicle. Aeroplane is a subclass to the vehicle. Okay, and then you have a lorry is a subclass to the vehicle. So what is an instant? You have maybe a car plate ABC 1 2 3 4. That's car plate 1 2 3 4 is a instant. It's an instant to the subclass called car. Okay, so there's a difference between instant and is a. Okay, so Xinchang is 5 years old. Is Xinchang still 5 years old now? Anyone? Xinchang fans? Yeah, you. How old is Xinchang? 5. Forever 5.
Yeah.
Why?
Because of that.
Why forever 5 years old?
Don't know. American cartoon Simpson also
Oh,
forever.
okay. But I'm not favorite of Xinchang lah, so a bit rude Xinchang, a bit hamsak lah. Yes but I never watched lah. I know that it's very hamsak. Okay, so it's 5 years old. So how to represent this in the semantic networks? So we know that Xinchang is one of the concepts. 5 years old is one of the concepts. So we want to join these two concepts together. So Xinchang 5. Okay, so age here. So and then you have to take note on this the error here lah. So we cannot put the 5 back to the Xinchang. It doesn't make sense, right? So we know that Xinchang age is 5 years old. If you put the errors in the another way around, then something wrong. It's wrong. Okay, Tweety the bird can sing. So we know that Tweety is a concept, bird is a concept, sing is a concept. So we can put Tweety. Okay, Tweety is one of the example. It's instant to the bird. So this Tweety can sing, right? So if you don't want to put the can, also you can put ability. Ability sing. So it is very freestyle. You use the semantic networks. So why semantic network is very important? One of the reasons is it helps the machines to analyze or to interpret the concept between each other. For example, if you go to the Google search, you type what is authorities, Then based on this map, the Google will return you, or ostrich is actually a bird, okay, which can run and it is very tall. So it will show this relationship, then it will return you the proper message back to the user. Then you will type what is animals? Maybe it will say animals can breathe, has these properties, has skin, can move, and then it will provide you some of the examples. What are the example of animal? Then it will provide you a bird, fish, and so on and so forth. Okay, so this is one of the this is how the so-called the search engine works. We have this map, so the so-called engine will try to analyze. You're looking for animals. So what are the concepts that link to animals? That it will return you. It will return the result to you on the page, in the Google search page there. Okay, so this is one of the examples of maybe questions. Represent the terms below in one semantic network. Edward is a vampire. Edward's girlfriend. Bella is a human. Jacob is a werewolf, and Bella are childhood friends. So werewolf is the enemy of vampires. Anyone?
Huh?
Yeah? You've got the two timples here. Anyone? Nearby? Outside lah, easy to walk here. Blender, okay, blender. Draw some picture for this question one. Semantic networks. Okay, good. Brandon is a vampire. Brandon girlfriend, what is your girlfriend name?
Nicola.
Nicole is a human.
Huh? Oh my god. Yeah.
Brandon is a?
Brandon
Brandon is a Hap Sap Low.
Brandon has 10 years experience.
Of what?
Hap Sap. Sexual harassment.
Thank you very much.
Brendan, in love.
Huh?
Edward's girlfriend.
Where girlfriend broke up. Okay, thank you. So let's see. Okay, Edward is an empire. So Edward is instant. Edward is a subclass of instant.
Instant.
Instant, no? More appropriate to put instant, right? So
Yes.
this one should be an instant. Edward is one of the example because you have others vampires, right? So just one of the example to vampires. Okay. So Edward girlfriend Bella. So what is the relationship between Edward and the Bella? Is a girlfriend of Edward. So Bella is a human. So Bella again is a instant.
Instant.
Instant. Okay. So it's a human. So, Jacob, what is the relationship with Jacob? Is a verb. Again, this is an instant. Okay. So Jacob is a verb and he's a better childhood friend. Okay, and the last one is the enemy. Okay. Okay, for a vampire. Alright. So it's very simple. If you have these kind of questions, you don't make any mistake. Okay, so kind of bonus mark. So you have a concept, you have a relationship, you just join the concept using the ages together with the label, a proper label. Okay. So this is one of the past year questions. Yeah, I give you about 5 minutes. 5 minutes to try these questions. Represent the terms below in one semantic network. So in one, so it means that in a whole, you cannot separate into different or partitions semantic networks. When traveling to a new place, there are 3 options of staying in: hotel, farm, homestay. 3 lodgings offer a variety of facilities. There are animals in farm, rabbits and sheep are both common. Homestay, on the other hand, have a shared lounge and free Wi-Fi. When you play aeroplane. You doing recording? Recording. Thank you.
星姐这样做，他只有3个 facility，不是只有2个吗？他骗我。顺便想说，啊，睡。不要睡这里。
有故事。
Brandon, you point one of your friends. Which one that you liked the most? What's the name?
Brian.
Oh, Brian. Okay. Brian? Brian? The answer is here. It is the answer.
我的996，好意思哦，我可以看到。
You can zoom in. You can.
Mine is small like shit.
真的要命。
1, 2, 3, 4, 5, 6, 7.
喂，
Yeah, compare your answer with this answer. So
他给了
we have a three launch, right? So have hotel, farm, homestay. So they has a facility and then water heater and sauna is because they are subclass. So homestay has share launch and has a free Wi-Fi. Farm has animals. Sheep is the animal. Yeah. Okay. Very simple, right? Okay. Hmm?
When do we use this and then for instance?
Instant we use when is so called what like
properties.
is we use is when it is a subclass. Okay, for example, you have a vehicle. So car, airplane, trains, they are all a subclass to vehicle. Okay, so maybe under the car you have one instance of car with the car plate number ABC1234, and this car here is actually one of the example to the car. So you have so many cars, right? So then this is just one of the example. This is instant. Okay.
Can we say that the sauna and the water heater is an instance of
They are actually one concept. They are actually one a class. They are actually one. They are considered because under the facility there are so many classes. You have what sauna. You have a water heater. Maybe you have so-called the washing machines. But then under the washing machine you have maybe washing machine, the brains, kins, and then model ones. Yeah, so that will be the example. Okay. All right. So it's not difficult, right, for semantic networks. So it's quite simple. As long as you identify the concept, the ideas, then you can actually join the concept together. Okay, so we have more questions here. So begins like you have a university is one of the top 20 university, established in 1950. So blah blah blah. So this one I let you try it at home lah. You try to identify the concept as well as the relationship. So you do yourself lah. Okay, so I just want to show you how do we build this semantic network using the Python. Maybe you got okay, we learned this theory, then how? So how to put it inside the Python or how to build the semantic networks. So one of the example is the WordNet that already built by someone by this Princeton universities. So how about let's say now we would like to build our own semantic networks. So there's quite many library and variables in the Python here. One of the famous one is called network X. So one of the library that you can use to build the relationship. Okay, let's say now we like to have a relationship dog animals. So that is animals. Cat is animals. So animal is a mammal, right? So that's how we learn about the animal is a mammal. So this is where we add the relationship. So this is just a graph, right? How do you want to draw the graph using a thick of the edges, okay, and so on and so forth. So if I run this code, then you will see, okay, so you will see this semantic network. Animal is a mammal, okay, dog is an animals, cat is animals, okay. All right. So is there any questions so far for semantic networks? No. Okay, good. Then I will proceed. So this one we have learned just some examples of semantic network. Let's say you have a lower, the dog bite the Peter, the postman. Then you can say, okay, rower is just one of the examples. So instant to dog. So rower bite the Peter. Peter is just one of the example to the postman. Okay, so you can actually extend or modify this simple semantic network to a more complicated one. You treat this byte here as one of the event. Instead of just one of the relationship, you treat the byte as one of the event into this. Okay, you treat the byte as one of the event, and then you have you can create one subclass or one example. It shows that this big B here is one of the example. So in this event here, who is the agent? Lower. What is lower? Lower is the example. So inside this event here, who is the victim? Peter. Who is Peter? Peter is one of the example to the postman. So there's no wrong or right. You can use this way or you can use this way. Okay, it's up to you. Okay, so this is non-quantified semantic networks. Non-quantified means that the event is specific. You know that Rover will bite the Peter. But sometimes you may have some statement, a general statement that shows that it's a quantified statement. For example, every dog bite postman. Okay, it is a general statement. So if you have a quantified so-called quantified terms in your statement, for example, every dog, some dog, then you cannot use a simple semantic network to represent the knowledge. Instead, you have to use a partition semantic networks. You have to use two different semantic networks to join them together. Okay, so we can actually draw the semantic network for dog has bitten the postman first. Okay, so this every here is actually a quantifier. So we leave it first. Okay, we draw the semantic network for this part. So we know that this is a bite event. So B is the instant of the bite, and then inside this event, who is the agent? Okay, we have a D here. So what is D? Is an example of dog. Okay, what is P here? Is just an example of postman. So this is one of the semantic networks. Then we create another semantic network here. We know that this is a general statement because it's not specified like the previous case. So we know that every dog. Then we create a general statement. And then G here is just one of the example. G is the example to the general statement. And we point this general statement here to this semantic network to join these two together to show that, okay, this general statement form this event. At the same time, you have to find which so-called concept is having the quantifier. Let's say this is dog, every dog here. Okay, every dog. Then we join this every here into the example. And this D here, it shows that every dog. So this symbol is referred to every. So it means that every dog bite the postman. Okay. But this is not very important, just additional information to you. If let's say we have a so-called the quantifier every. If you have a some dog here, okay, some, then you have to use this symbol. So this is all. Okay. So let's say now you have every dog has bitten every postman. Okay, if you have every dog has bitten every postman in this case, then you have to join this statement here. Okay, create one line to show, okay, all postman, all dog here, and then at the same time you create another line to link to this postman and put this symbol. Then from this diagram we know that every dog has bitten every postman. Okay, is that clear? Okay, so what? Okay, just now we learned about binary predicate, which is the direct relationship. For example, the first one, Ronaldo, Real Madrid. Okay, so we have a Ronaldo, Real Madrid is very simple. Then you have a two concept here. Okay, Ronaldo, or maybe team is Real Madrid. Okay, this is binary. But let's say now we have a non-binary predicate. What happened? So this second example here shows non-binary predicate. You have a three concept here, Real Madrid, MU, and 1-3. Okay, it means that in one event you have a three predicates, three objects here. So how to generate the semantic network for this case? Then you have to think a keywords, then how to join the concept together. In this case, I'm going to use a keyword called features. Okay, features is one of the subclass to the football game, and then you join the three predicate here. You have a Real Madrid, MU, and 1-3 here. So we know that away team is Real Madrid, a home team is MU, and score is 1-3. If you cannot think the keywords that how to join this predicate, then you can just use the terms called event. Okay, so event is just one of the example. For example, in this case, John gave the book to Mary. So we have a John, a book, and Mary, right? Three predicates. So this event is about give here. So we can just create a one keyword called event. So what is this event? This event is actually one of the example to give. Okay, so in this event, who is the agent? John. Okay, so who is the receiver? Mary, right? Mary is the receiver. And what is the object here? Book. Okay, book here. So you can just write the name of the book lah, and then book 69 is one of the example to the book. Okay. Yeah, so if let's say now you have a question here. Simon has what? Okay. So based on this semantic network, then you can tell, oh, Simon is actually a human. Simon has nose. At the same time, Simon is a mammal and has skin. Then based on the third question, then you can say, oh, Simon has nose and has a skin. And this is how a machine interprets also based on the semantic networks and return the appropriate response back to the user. Okay. So sometimes we use the semantic network to compare the two objects. For example, in this case, okay, so we want to compare the height of Dave and also the Steve. So Dave, okay, so you can point to the H1. You just create one variable here. Okay, it shows that this is just one of the circle of variables. Then this variable is greater than this variable. Then you can put a value here. What is the relationship between these variables and this value? Okay, 160. Okay, it's greater than. Okay, so there are many ways to represent the semantic network. If you don't want to create the two variables here, then you can also put maybe if you don't want to create this variable, maybe you can write in such a way. And Dave, okay, the relationship between that and so this is a value maybe 160, right? Okay, and then you have another concept called Steve. Okay, also you have a height 158. So this is greater than, not greater than, also can. It depends. It's very flexible to use semantic networks. Okay. Okay, so this is just a prologue. Forget about this. It's just one of the techniques. How do you code your knowledge? After you prepare the knowledge, right? After you prepare this, you have to put this into the coding. Just like how I put the code inside the network X just now. So what is the advantage of and also the disadvantages of the semantic networks? Easy to visualize, right? By looking at the semantic net, then you know what is the relationship between one and another. So related knowledge is easily categorized. The knowledge engineer can arbitrarily define the relationship. Limitations is no standard. As I mentioned, it depends. Every user may have a different interpretations, use different keywords to represent the concept, and it is not suitable to describe the attributes. Remember, it is not suitable to describe the properties or the attribute. Okay, it is not suitable. Okay, so next one we have a conceptual graph. So I'm not going to details about talk about the conceptual graph. The ideas of the conceptual graph is about the same like the semantic networks. Conceptual graph used to represent the relationship, but the difference here is semantic network is more towards a binary relationship. Okay, binary graph is to show the simple relationship. But the conceptual graph here is mainly used to solve a more complicated, complex relationship using a bipartite graph. Okay. Okay. If you know the semantic network is good enough already. But this conceptual graph is just additional information to you, how to represent the knowledge in a more complicated way. One of the main difference between the conceptual graph and also the semantic network is the node. Right. Just now we have a node to represent the so-called concept, and then we have an edge here to show the relationship. By using the conceptual graph, we want to transform this into this. Okay, Ronaldo. Okay, so team Real Madrid. So this is by using a conceptual graph. It's using semantic networks. So we have to use a node to represent the relationship instead of just hang upon these edges. This is the only difference. Okay? So something like this lah. So just now we just put the arrows and then put the relationship. But in the conceptual graph, we have to represent the relationship using the what? Using the nodes. This is the only difference. If you would like to know more about the conceptual graph, then you can explore lah by yourself. Okay, I'm going to go to the third one. It's called end-of graph. So end-of graph, also known as the hypergraph. Sometimes it's called as the inference networks. Infer means that to interpret. Okay, so mainly end-of graph used to represent the rules. To represent the rules. It's not the relationship, but more toward the rules. Okay, let's say now you have these examples. Okay, so this is actually a rule base. You have 3 different rules here. If John smiles, then he looks handsome. If John is tall and strong, then he looks handsome. If John does exercise, then he is strong. Who is John? Anyone named John? No. Okay, so let's see how to build the end-of graph using these 3 rules. If John is smile, so this is the first condition. Smile, then he look handsome, then we put an arrow here, so handsome. Okay, look at the second one. If John is tall and strong, if John is tall and strong, okay, John is tall and strong. So if we have a keyword called and, if we have an and, then we put a join here. Okay, to show that you have to fulfill these 2 conditions in order to give you this conclusion. So we don't have a join here because rule 1 and rule 2 are separated. Separated. Then the third one, if John does exercise, then he is strong. So you does exercise, then you are strong. So this is the end-of graph to show the conditions, which condition that can lead you to the conclusions. Okay. Okay, so you have this exercise or not exercise question here. Can you try these questions? It's one of the puzzle questions. Before you zoom in the answer you try yourself first, then and you compare. Okay, so forget about the CF value here. So this is so-called uncertainty factors that you're going to learn in the chapter 12. Forget about this. You just based on these 3 rules, build the end-of graph or the hypergraph. Okay, to test your understanding. So I'll give you about 5 minutes now, 5 minutes.
thinking. After you finish, you come order. Maybe you lah, handsome boy.
The guy with the beer more.